Alright, this first one. This one right here. What we're going to do is we're going to factor the numerator and denominator first. Always factor, factor, factor. Whenever you have rational expressions, factor them. Alright, you guys got to be monsters at factoring. So the top, I'm looking at this one, and I can see that I could take an x out of both of those terms. And then I can see I can factor some more, but I'm going to wait on that. I'm going to factor the denominator first, and then I'll factor the top some more. For the denominator, I'm looking for what multiplies to give me negative 2 and then adds to give me positive 1. So I'm thinking, what is that? Negative 2, no, positive 2 and negative 1. Alright, so x plus 2, x negative 1. Alright, that one, definitely, if you haven't factored a lot, you should probably write stuff down so you don't mess that one up. Now this one right here is special. He's called a difference of squares. You see this minus sign? That means difference. You see both of these terms? Those are perfect squares, so we call this a difference of squares. When we factor this, we can factor it as x minus 2 and x plus 2. Why? Ooh, why is a good question. Here, let me show you. Let's look at a different difference of squares. Let's say I had x minus 5 and x plus 5. If I were to multiply these together, I would go x times x, which would be x squared, x times 5, which would be 5x, negative 5 times x, which is negative 5x, and then negative 5 times positive 5, which is negative 25. What happens to my x terms? They cancel out. So I get x squared minus 25. Now, if I was just looking at this polynomial right here, and I was told to factor this, I know that this is a difference of squares because x squared is a perfect square, 25 is a perfect square, and it says minus. Whenever that happens, I know right away. I bust out my template. A difference of squares factors out to be this: a plus and a minus. What is the square root of x squared? X. What is the square root of 25? It's 5. So, difference of squares should be really quick for you to factor. Just like this one right here. So that one, I factored really quickly. And then I write the bottom out. I have x plus 2, x minus 1. And now I can cancel things out. Let's see. I got x plus 2 and x plus 2. And then I'm left with the top being x times x minus 2. And the bottom being x minus 1. Alright, but we always have to consider the domain when we do these, when we simplify rational expressions. What can x not equal?
1.
Yes, it can definitely not equal 1, but you're only looking at the answer. What about the beginning? I know it can't equal 1 by looking at this factor. What can x also not equal?
Negative 2.
Negative 2. If I plug a negative 2 in right there, what is negative 2 and positive 2? 0. So x cannot equal 1 and negative 2. Alright. Okay, the next one, this one's just gnarly with factoring, okay? So the first thing I'm going to do is I'm going to make the top one in standard form, just because I think you guys like it better in standard form. Can you factor it this way? For sure, but I think you like it better in standard form. So I'm thinking standard form, I'm picking the terms, see there's 3 of them up here, that has the highest exponent. So I'm going to put negative x squared right there. And then I'm going to put the x right next because that's 2 and then an exponent of 1. And then we have the number with no exponent because he doesn't even have a variable. Okay, the constant. This is standard form. We normally like the x squareds in the beginning, but you don't have to do it that way. You can factor just as it is. But I'm trying to do something that you guys are familiar with so we don't have to spend too much time on it. Alright, and then the bottom we have 2x squared minus 9x plus 4. Now this one has a huge speed bump in it. Okay, and I'm glad it has a speed bump because I want you guys to see it. But besides that, maybe out of 10 or 15 problems, you might get one problem like this where it has this huge speed bump. So here we go. First thing is I don't want a negative in the front. If I have a negative in the front, then that means I have to use grouping. This one right here that I factored earlier, I didn't have to use grouping because the first number was a positive 1. So I'm going to take a negative 1 out from the beginning. In fact, I'm just going to do it right here. take a negative 1 out, so now it changes all the signs. It's just a little math trick that I've learned from the past. Now I can factor this inside. It's just x squared minus x minus 12. If I was doing the big X, this is what it would look like. I have negative 12 right there, and then I have negative 1. What multiplies to give me negative 12, but then adds to give me positive 1?
Negative 4.
Peter. Alright, so we got 4 and 3, and the 4 is the one that's going to be negative, so that we get a negative 1 when we add them together. And so now I have negative 1, and then x minus 4, and x plus 3. Now we have the bottom. We have 2x squared minus 9x plus 4. Now this one we can't get rid of. We can't take out a 2 from this polynomial, so we're going to have to use grouping. Now when we group, the strategy is to split up the middle term. Are there other ways to do this? Yes, there are other ways to do this, but I'm just going to do it the way that I know best. So to split up that middle term, I'm going to use the big X again. And I'm going to put negative 9 on the bottom, and on the top I put 8. Where did I get 8? You get 8 by going 2 times 4. The first term times the last term. Okay, then I have to think what multiplies to give me 8, but then adds to give me negative 9. Think about that. Negative 8, negative 1. Okay, so I have negative 8, negative 1. That is going to replace the negative 9. So watch how I write it. It would be 2x squared, and it doesn't matter the order that you put the negative 8 and the negative 1. You could do whichever one you want first. It's kind of cool. It works out both ways. Alright, so this is this polynomial, the new one that I wrote, is the same as this. It's just not simplified. But now I can do something called grouping. When I do grouping, I take the first two terms and the last two terms and kind of group them together. What can I divide both of these terms by? 2. Is that the biggest number I can divide both of them by? 2x. And what can I divide both of these by? Yeah, just a 1. Now the question is, do you want to divide it by a 1 or a negative 1? Let's find out. For the first one, I take a 2x out. This is what I get. 2x squared divided by 2x is going to be x. Negative 8x divided by 2x is going to be negative 4. Is everybody cool with that? 8 divided by 2 is 4. The x's cancel out. Alright, now this next one, if I take out a 1, will I get the same thing in my parentheses as this one? Negative 1 divided by positive 1. That would be a negative x. Do I want a negative x? No, I want a positive x. So what should I take out? I should take out a negative 1. So let's change this to a negative 1. Now I have a positive x. What do I get when I go 4 divided by negative 1? Negative 4. Now do I have the same thing in the parentheses? Yeah, that means I can simplify this even more. I have 2x minus 1 and then x minus 4. It's almost like you're factoring out a GCF again. But your GCF is weird. Your GCF is x minus 4. Wow, look at all this stuff. Let's clean this up a little bit. Now, that 2x is adding to the negative 1. Sorry, I just want to make sure I said that so you guys don't think you're supposed to multiply these guys right now. Alright, so like I said, let me clean it up. We have negative 1, x minus 4, and then x plus 3. Now on the denominator, we just factored that out to be 2x minus 1, and then x minus 4. And then we're going to, let's see, we can cancel out x minus 4 and x minus 4. And then our final answer is going to be negative 1. We'll just put a negative in front of x plus 3 over 2x minus 1. That's our final answer. Now at the very beginning we had the denominator is this. This denominator factored is 2x minus 1 and x plus 4. So that means x cannot equal positive 4 because that would make this factor equal 0, and it cannot equal positive 1/2. Now I can do that in my head pretty quickly. If you can't, just take 2x minus 1 and equal that to 0, add 1 to both sides, then divide both sides by 2x. I'm sorry, just 2. So if I divide that by 2, divide that by 2, you see your 1/2 right there.